Hey, what's up everybody? Welcome to another 3D Hangouts, episode 183, Minifigs and Starman.
That's right, Tyree. Today we're going to be looking at protecting your webcam with Lego compatible webcam cover and a teeny tiny Adabot Mini Fig.
Right. We're going to do some shop talk, a little bit of layer by layer, take a look at community makes, all that and more on, you guessed it,
3D Hangouts.
3D Hangout.
Excellent.
Hey, what's up everybody? Welcome back to another 3D Hangouts. I'm Noah Ruiz, the designer here at Adafruit, and joining me every week is a puzzle piece, a sad puzzle piece. Just kidding.
What's going on, everybody? I'm Paige Rose, Creative Tech here at Adafruit, and every week we come to share 3D printed projects featuring electronics from Adafruit.
That's right, this is where we combine 3D printing and DIY electronics to inspire you folks live, because we're doing it live. Thank you everybody in the chat room for joining us. We do this show every Wednesday at 11, I almost said PM, 11 a.m. Eastern time. We need more coffee and such. I hope everybody's doing really good. It's Wednesday, you know what that means. It's leftovers today. Let's start the show off with today's coupon code is, of course, Adabot. So if you check out in today's, come on, help me out here, Ben.
Use coupon code Adabot to get 10% off your order. Expires at 11:59 p.m. tonight, and it works on everything except gift certificates and Adabot subscriptions.
Yeah, guess what? We have freebies this week. All month long we've been having this great deal. So if you go to adafruit.com/free, you can check out all the deals. If you spend $100 or more, you get a Perma Proto. If you spend $199 or more, you get free UPS ground shipping for US continental only. And for $299, you get all that plus Circuit Playground. But check the website for all the details, because I may have misspoken. It's a little early.
Well, supplies
Back to
last.
coupon code. Yeah, so we have a fun project this week. Let's just jump right into it. Where's my project thing? I think it's gone. There it is. Some things moved around in Wirecast. How quaint.
Wirecast changes everything on you right before we go live.
Yeah, that's it. Okay,
this week's project is quite relevant with all of the data privacy concerns going on with Facebook. It wouldn't be surprised at all if they had some apps snooping on you through the webcam. So being the fortune teller that PT is, he suggested we make a webcam cover a couple weeks ago and make it Lego compatible while adding on there as a bonus a cute Adabot Mini Fig. This is supposed to coincide with Adabox 007, which is a spy theme. This is the Lego brick webcam cover with super cute little Adabot. Go ahead and jump into the learning guide. You can take a look at all of the super easy assembly and just some of the 3D printing settings that we're using for this. Super handy in terms of being able to decorate and protect your screen from any apps that might be spying on you. We're using the 0.25 millimeter nozzle to print out all these tiny little intricate parts, but this should work just fine with a 0.4 millimeter nozzle. This was inspired by one of the Thingiverse posts a couple years back. Somebody made some remix of Lego Minifigs, and it made us realize that it is definitely possible to do this with an FDM 3D printer. We did have some people test these out on SLA resin printers, and it worked just fine on those as well. So if we go over to the overhead and take a look at the detail on this, I have to do a lot of palm holding here to get this to focus. And check it out. Dual extruded brings out so much detail just by having that extra color on there. We do have a single extruded version. Looks like this. And we did take some design considerations in terms of keeping the original artwork the same. So we gave Adabot the boxy body. Typically, minifigs usually have like this trapezoid sort of looking body, but as you can see, it looks kind of funny when compared to what the original artwork looks like.
Yeah. Can you compare them to like C-3PO maybe?
Oh yeah. So of course you can now have Adabot hang out with all of the popular robots on the block.
That's great.
But yeah, it definitely looks a lot more better instead of having or staying with the typical trapezoid sort of body there.
Yeah.
So it made that design consideration, and it did not affect him being able to fit into vehicles, so that works very well for that.
Yeah.
And of course all the pegs, all of the body parts are all compatible with all of the different minifigs, so everything all snaps in like a typical Lego would. So all the legs, the torso, the head, all of the little arms and everything all works. Of course, as you might have seen in the video, the hands are perfect size for holding your USB programming cable or charging cable, so that could be handy, ready to go whenever you need to plug those in. One of the things that I thought would not work is the little antennae on the sides, and those held up very well. I'm very surprised. We took this all around like Disney and having it in the pocket, taking some pictures around it, and it held up very well. None of these broke up.
Quite a few times.
Dropped it quite a few times. Also have the nice little stud on the top. Obviously, it's not going to work with hats or helmets, but other headdress accessories, which it's not coming to mind right now, should work perfectly.
John K has a great question. How would you do 3 colors? It's sort of an illusion, right? Not illusion, but
I mean,
sort of a trick.
You could. Oh,
how do you
well,
do
these
3
are
colors, right?
Yeah. So either
it's sort of a trick. It's actually multiple pieces, so you print the head separately.
So the torso is printed separately. Actually, I could show you what that actually looks like when it's printed separately. Comes out like that. So we're using support materials, or supports and brims on the bottom. And I just wanted to illustrate just how well the supports come out when you're using a 0.25 nozzle. These are right here. Yeah. See that?
Sweet. Live.
Comes right off.
Wow.
It's pretty cool. Nice little detail on that.
So there's a big brim on the bottom of this, and this helps keep the support material and the thin walls on the bed. So we're printing this on a heated glass bed.
Which I know, yes, we will take a look at that link that Kirby sent over for the PEI sheets.
Yeah, that's cool.
And another thing that I wanted to show off too was just how intricate those support materials can get on there by taking a look at how the arms are actually oriented to print out.
Let's go all the way close. It's closer.
This is like crazy.
It's crazy close.
The amount of detail you're looking at. One already fell off here, but this is how small the support material looks like on here.
Closer. There you go.
Look at that detail.
You can see
it didn't touch any of the walls around there. So I'm gonna guess you could do this with a 0.4 millimeter nozzle, but you're gonna get a lot better results with a 0.2 mil nozzle. Because wow, look how teeny tiny that is. You can see like the tip of the tweezers there.
Yeah, it's kind of amazing, really. Did you mention the layer height is 100 microns?
Yeah, so we did print at 100 microns for the head, just to get that detail in there. And then for the body parts, we're using like 150 microns, but you could also do 100 microns for that. And then this is what the legs come out looking like. Just lay those out right there. There is going to be a couple bit of cleanup that you are going to have to do, specifically for the mounts on the inside here. Typically the Z seam will be on the inside here, so you are going to have to remove that just to make sure that your tolerances are nice and they work well with the little input here on the torso connector. If we go ahead and jump into the guide, we can take a look at more structured way that this is built for the 3D printing part of this. So again, this is really highlighting, it being a webcam cover, but of course, because it is Lego compatible, you are getting that extra bit of decoration and having some useful things that can go on your desktop. A little bit beyond the stickers to customize your desktop, so definitely gives you more creative freedom in setting this up. All of the files are in Fusion 360, so you can go ahead and modify any of the tolerances for your specific printer. And Noed did a really good layer by layer on the cover part of this.
Yeah, which we should embed in this. We should embed it in this page. We'll do that
whoops.
after. Yeah.
Yeah, so go ahead and check out that, and you can make these different sizes and lengths in terms of the vertical and horizontal as well. You can make different customized shapes to fit whatever creation that you want on your desktop. I think one of the coolest ones that we showed in the video is this little loader extractor dealy here. All those work very well.
Yeah, I saw a comment in the video that was suggesting maybe you could do this to an existing Lego brick. I just want to point out the major differences between these camera covers. You see the slit here. If you try to do this with a regular Lego piece, well, first of all, Lego pieces are hollow. This is more solid with a pretty decent infill. But the way they kind of connect and grasp onto your monitor is with this very precise, dimensionally accurate slit here. So this is for more of a laptop monitor, and the bigger ones go on something like a desktop, like this. So you can see it's really, really big. So because of that, you'll notice that the widths are different, and that's to accommodate for this sort of large piece. Another kind of design consideration is the length, the tallness of the Lego brick is actually a little bit bigger than a regular Lego brick, and that's just to accommodate for, well, the webcam.
Yeah.
So if I try to follow the exact same Lego dimensions,
you're not going to cover anything.
It's not really going to, yeah. So you can see how it's kind of different in width. But the distance between the studs is really what makes Lego Lego. And of course, the diameter of the stud is something that definitely you'll need to either prototype and test before you kind of print this whole thing out. So that's one of the reasons why we really worked hard to make this a parametric model that's easy enough to modify without having to kind of modify a sketch. It's more about just opening that user parameter window and just changing a value. So it's pretty neat.
What you are going to definitely have to do is, as we saw, printing a single extrusion version and a dual extrusion version of the covers yielded different tolerances results.
It's worth saying that again, yeah. So the stud diameter on this guy is what, 5 millimeters?
Yes.
And then on this guy, it's like 4.8 millimeters.
Mm-hmm.
Same model, well, sort of the same model, but the same printer, really, printing. And once you introduce to the dual extrusion, these kind of, or this one gets a little bit shrunked, right?
Mm-hmm. For whatever reason, yeah. We did have to adjust those between printing dual and printing single extrusion. And again, like you said, this was the exact same printer. All we did was introduce another nozzle. For whatever reason, toolpaths changed slightly for that, so we did have to accommodate for that in the user parameters.
Yeah. And this as well is also parametric, so you can change the distance between these two walls. And there's a little bit of overhang there. So really depending on whatever you want to attach it to, whatever monitor you have. I mean, there's so many different monitors and computers. This one particularly is for a 2016 iMac, I want to say. But it can also fit other iMacs and other desktops that have sort of a thicker bezel. So that's kind of a little bit of detail in there. Again, all of this is kind of changeable. The stud count can increase from the width and the length of it. We don't have an example of that, but definitely could. And let's jump back into the guide. Oh, nice, yeah. Liz is saying she's going to try to resize it for her Logitech webcam. Yeah, that's even...
It's a really good idea,
It's even different, yeah. I'm looking at my Logitech and I'm like, how thick is that?
Yeah, you definitely have to do some adjusting to that, but it should scale easily with the way that you set up the sketch-driven design for this, so it should scale properly. Plus, with the back here is connected, so it does. It's pretty smart in the way that you do have it scaling.
There's some constraints in there that'll just kind of push that that surface outward.
Yeah, and again, for like video production and stuff like that, you can attach other things onto here, since the figures and Lego, bricks in general do snap on very tight to that. You do have a nice hold on that for if you wanted to attach, other things to it.
Right.
And then Bill from 18 Makers is saying, is the tolerance differences because you were printing an U shield? Actually, on the Ultimakers, there is no print tower or U shield required. The way that they work, it actually retracts the nozzle upwards,
and
then cools it down. Yeah. So whatever it was, for whatever reason, that they have their tool, the tool paths generated for the dual extrusion. That's what's changing in it. Moving on into the guide. You can get all of the dual extrusion parts, or if you want to modify the Fusion 360 file, that's where all the links for that is. It's actually been available for a couple of weeks now, the Lego brick part of that, or the cover-up part of that.
Yeah.
And this would be good for attaching, I don't know, like AT devices maybe, like on top of a screen or monitor.
Sure.
I saw some people commenting that they were actually using like duct tape to attach some of these before, so this could be a nice way to add something that's removable if you wanted to switch things out. And I just go over orienting parts for this, for printing and setting up your brims and supports for that. Some very handy updates to Cura, actually, which we'll talk about in Shop Talk, for selectively placing your supports, which is really cool. So we'll talk about that.
What type of support did you use? Is this like the regular zigzag?
So I used the triangular support pattern for this. And that generated the supports that you saw a little bit earlier, where I was showing how thin those supports were inside of the arm.
The circle little post?
Mm-hmm.
Those are triangular?
Yeah. That's weird, huh?
It is weird.
And moving down to setting up your dual extrusion, how to set that up and add a brim to that. And this is actually what it looks like when it comes out. It looks super messy, but when you clean it up, definitely recommend getting a brand new blade. Yeah, brand new blade on your X-Acto hobby knife, whatever, and that should clean up quite nicely. Take that off like that. And all these tiny little retractions here, you have to go like on the underside of those, lift up to remove those, and it actually cleans up very nicely. So if you print this out and have some doubts like, oh no, it came out like a mess, you just got to take some time to actually clean those out, and it comes out really beautifully.
Well, Linsky has a great question. Do we have a video on how to print and model for a dual extruder? I think we did.
We have a whole video on just setting up dual extrusions for that. I think we did it last year, but it was actually for the Flash Forge.
Yeah, it's a lot more messier. You have sort of a different method of dual extruding.
You do have to use an U shield on the Flash Forge for that.
Yeah.
So there you go, and you can see a little bit of drooping on that, but you can actually take your hobby blade underneath the mouth area and pull upwards to get all that droop out, and very carefully slice that off, and it cleans up pretty briefly. Same thing with the eyes, go underneath it and then pull up. That's a technique for that.
We're getting all these requests now for different Circuit Playground characters. So
I will definitely do that. Yeah, these are so fun to do. And then on the inside, you can take your precision flat pliers to grab the supports that are in there. Oh, I hope I got that on camera, ripping that out.
There we go.
It comes out really nicely. You do want to make sure you set your support material to touching bed, not everywhere, because then it will add a bunch of unnecessary support materials in the cavity in here, which will be very difficult to remove. And then under the ears here, and this could be for anything, crush it like that to easily remove it.
Patrick, what material is this?
This is just PLA.
Regular PLA?
Regular PLA, yeah.
If we were to use maybe ABS, PETG, what are the other ones? CPE, all those sort of more industrial strength materials, you definitely would get different tolerances.
Probably, yeah. I mean, there's different temperatures for that.
From something like ABS. But we definitely could do ABS.
Yeah.
Although we're limited in colors, sort of. at least the colors we have on hand.
Yeah, we did try different blues for this as well, and it turns out that the neon actually matched the best for what the artwork originally looks like. But you can go ahead and make, you know, different colored Adabots.
Great. PLA is all they can do. Yeah. Yeah.
Oh, yeah.
We tend to stick with PLA because we know the majority of folks, and it's just easy to print with.
Yeah, we get so many requests for testing out other materials, but
we did recently, not really, but we mostly try to avoid other materials.
I know, because it's such a
When we're doing, you know, something that really needs maybe a robot that needs to have a strain. And
yeah, that's where it would make sense.
Yeah.
For the time being, we're neither right now. Yeah, I just wanted to show off this super cute Adabot.
So the claws grasp onto, you know, your common Lego accessories like this shipping. Adabot shipping.
This is what it looks like when your orders are shipping. Adabot goes out, grabs all the boxes.
Yeah, one day this will be true.
So moving on in the guide, if you jump into the quote-unquote assembly of this, since it really is just putting a minifig together.
We have an animated GIF.
Oh yeah, everything I just talked about I showed there. One of the things you want to watch out for is when you get these off the plate, start testing them out. Use a a genuine Lego brick to make sure that the studs are all working with the feet on there. And if they're not, go ahead and check the underneath inside the cavities and make sure that there aren't any little droops that could happen with the feet. So if you take a look at the guide there, you can see where the Z-seams for some of those are, well, some of the drooping that will definitely affect you being able to attach these to a brick. Once you've verified this with a real brick, you can go ahead and test out your printed bricks to make sure that those tolerances are working as well. You don't want to test the Adabot on your printed brick only to find out that it doesn't work with the genuine Lego bricks. So definitely test that out first in that order, and then you can adjust your tolerances based on what the sizing is on the cover-up brick.
Yeah, I also want to mention, when I first started prototyping the brick webcam cover, my studs were set to 5 millimeters, and if you measure a real Lego, it's 4.8.
Yeah.
Right? So you could totally, you know, force a real brick onto.
You are going to damage.
But what happens is you loosen the tolerances for those bricks. So don't do that.
Which it happens over time anyway, but this just accelerates it, and you know. So moving on to after assembly of the minifig, it's really just cleaning the inside of the brick. If you did do the dual extrusion, there is going to be some cleanup that needs to happen on the inside, which I didn't show there. You can go to the overhead and see what I mean by that. It's just a little bit that will be right on the inside here. That could affect when you place it.
Correct.
Yeah, when placing it on your laptop or on your monitor, it will affect the tolerances on that. So you just want to clean that up right there. And again, use a new blade. You can't slip and cut yourself if you're using a dull blade.
Oh, yeah. Okay.
Yeah, it always increases the chance if you're using a dull blade because you're going to be applying more pressure and you might, you know, slip and let go. If you're using a brand new blade, it'll be effortless to clean that up. You also want to get these edges here too if you were indeed using a brim. And yes, I did load up that link that Kirby sent over for the PEI.
Okay.
We'll order it for the after the show. Test it out. Cool. And that's pretty much it. Super easy project. The only challenging part of this should be getting creative and making a nice little scene for that. Figuring out what characters would look good. Of course, I made this nice little castle to go along with the little scene on my desktop. And one thing that we did try was dual extruding it with a translucent material and seeing, we wanted to see if, like, when your webcam turns on, there should be like a little green LED that goes on with it. So I wanted to see if that would illuminate it. Looks great here, but in practice, because the LED is angled at a certain way, it only lights up like the very bottom of the lightning bolt. But still cool to try out if you have like any light bricks. Of course, we did make some light bricks, which we should have had in the video, and should have changed the batteries out to show that off.
Projects.
Yeah, But it looks really cool when you use translucent, dual extrude translucent material for this. And of course you could use this for other things like making a sign or something that glows really cool like that. Would probably suggest using something other than this gray, since it does have, it is a little bit slight opaque, yeah. Would work great with other ones, but super cool. You can have something like that. And it's so funny again how relevant this is with all of the data privacy concerns with Facebook and all that. Phil is like a seer of the future, fortune teller.
Okay. Let's see.
So super
on the guide.
fun project. Yeah, again, the most difficult part about this is making a cool little creative scene if you wish to do so with these. And of course, the usefulness of being able to attach other accessories to your computer workspace that might have been difficult before. It makes it a little bit less permanent, so you don't have to commit to taping or gluing something on. And yeah, that's this week's project. Super fun. Little Lego Adabot.
Cool. We got some comments. John's also wondering about acetone.
That would
vapor
look
with ABS.
So good in ABS, and if you did the
there's some caveats though with that method.
You might lose some of the tolerances in the arms.
Would, I think.
Like
you lose a little bit of detail and
you will
tolerances.
Yeah, you're definitely going to lose the little studs right here that are required that are keeping this nice and tight on the torso there.
Right. There's also other things like the.
You could of course accommodate for that.
What is it called? Polymaker.
Oh yeah, poly smoother. Yeah.
There's these other types of.
So those are other ways to go for that to make it like ultra smooth, because at 100 microns it's pretty smooth already, as you can see.
Right. And from a distance you don't see any layer lines.
Yeah.
Yeah.
Super cute little Adabot.
Very cool.
Print that out. And yeah, I will definitely look at, we should probably run a poll, which character should be next.
Adabot just fits so perfectly as a minifig because he's already a boxy robot.
Yeah.
So it just made so much sense.
Makes sense since hang out with all the cool robots. Oh yeah. And R2D2 there too, since he's
a little bit more wide.
4 studs wide, can't fit him on there. So really cool project this week.
Blink,
if you make one, definitely. Oh yeah, Blink would be so cool. Some cool articulation in there. So if you make one, definitely post and make on Thingiverse. And again, I want to shout out to, I have it linked in the show notes, the original, I want to say it's the original, maybe there was more before that, inspired by this Thingiverse post here, posted in 2015. And this is what made me confident that this would actually work, because he notes that he printed these on a, I think it was a Prusa style printer, with a 0.4 millimeter nozzle, using brims, rafts,
or brim, one of the other.
And these look pretty good for a 0.4. Look at this.
Sweet.
So this is definitely achievable with a larger size nozzle. Yes, MOSFET. Definitely.
Yeah, tribute to MOSFET.
Yeah, check it out. It looks really good.
Yay, 1-to-1 scale. Sweet. Quite a few makes.
Oh my god, yeah, there's a ton of remixes and makes from this. Cool. So it is absolutely possible.
Yep. And if you're wondering,
it's a really good way to tune your
So we've been
printer.
talking about FDM type printers, right? The filament-based printers, but there's also, of course, other printers like resin-based printers, like the Formlabs. What is it called? The Formlabs Plus. Yeah. So this was shout out to Amy Double D, who is a fellow maker, game dev. And I sent her these files to see if she wanted to print them, and she printed them. I thought she had like a regular FDM printer, but she printed them in the SLA print. So this is
very helpful
solid
to see
resin.
That it works perfectly too.
It seems to work, yeah. So there's little supports there. DLP requires a little bit of an extra step, a little bit of post-processing to cure the resin at the end of the print. So I believe it's you gotta let it cure, and then you can snap off these support branches.
Yeah.
Which is definitely necessary when you're printing SLA parts.
Yeah, work beautifully.
Yeah. Plus you get way more, I think, detail, right? With the SLA parts.
Oh my god, yeah, you definitely get a lot more detail.
Yeah. Sweet.
The tiniest detail.
It's Adabot went on a trip.
Oh yeah,
he went on a weekend trip, 2-day trip to Disney World. There he is at Epcot.
And we're only showing this just to illustrate how strong the
he's so
little
strong.
antennae were.
didn't stand
Dropped
up.
it several times. I had Gavin running around with it in the pool, and it all survived. So, very cool.
All right.
Yeah. Should have Noah and Pedro Lego minifigures, says Yanni.
We do have blockhead figures.
Oh, yeah.
That's
Steve
Josh made.
S. is saying that he's having trouble getting Simplify 3D to generate supports using a 0.4 nozzle.
Oh, no.
Check on lowering the pillar size. So when you go into your supports, there is the ability to adjust how big the pillars for all of the supports are. Try dropping it down to 4 millimeters, and that should generate. It's probably, I think the default for it is 8 millimeters, which is like big.
Yeah.
So try that. We will talk about some really good additions to support materials inside of Cura if you're interested in trying that out.
Yeah.
Take a look at that in Shop Talk.
We
Coming up in a little bit.
Yeah, real quick comment from Pine Tree Studios. He made his first Arduino project, the 10 LED Night Rider strip. It's never programmed in his life. It's 45 years old, next to NeoPixels now. I have project ideas for print stuff. That is awesome.
Sweet.
I invite you to come on the Adafruit Show and Tell, or post your stuff on the Discord channel. We have links up there, discord.gg/Adafruit. Whoa. Well, that's terrible. I spilt my coffee, but hey, no, phone's still good.
I'll clean it up. Move on to
Thanks.
the next thing.
It's a live show, folks. So, what are we prototyping other than spilt coffee? Well, shout out to Mike Judge on Twitter for inspiring the next project we're going to work on. So, this was brought to my attention by PT, Filteron. This is awesome. So, this is from Mike Judge. He is working on an LED trampoline. He's calling it a Trampole Lantern. It's pretty cool. You jump on the trampoline and a strip of NeoPixels or RGB LEDs light up. It seems like a fun project. So we made our own version. This is like a cheap $20 trampoline that's meant for like fitness and stuff. We got at Walmart. So fairly quick and easy project. There are these little 3D printed clips that sort of snap onto the pipe, the circular pipe that is the structure of the trampoline. And what I'm using here is a NeoPixel strip, a 60 meter, not 60 meter, it's 3 meters long, but it's the sort of medium density LEDs. So just a couple 3D printed parts. It's like 10 or so little clips, and it's all running off of a Trinket M0. So it's powered by a Circuit Python, and we're using a USB battery bank to provide power for it. Yeah. So we weren't able to run the rainbow animation because it's kind of kills the RAM on the Trinket M0, but okay, enough of that. Kind of fun. So I just wanted to share with you guys the breadboard circuit that I'm kind of working on. So from the tweet, Mike Judge says he's using a, what do we have? One of these guys, which is a sort of a really inexpensive vibration sensor. So if we take a look at a vibration sensor, you haven't seen one before, we have a product page that shows you a cross-section of it. It's basically 2 metal leads, and inside the little capsule is a spring, and whenever you flick it or vibrate it, it kind of closes the circuit, right? So it's basically a switch, right? 2-lead switch. So I have here my Trinket M0, and these are dot stars. We're probably going to use NeoPixels, but this is what I had on hand, so these are dot stars. So the idea is to jump on the trampoline and light it up. Hopefully we'll make this a little bit more advanced, so it's not just on and off. Maybe we'll do some fading animation stuff with help from Katney, who wants to help out here. But that's pretty much the circuit. And I wanted to put this together just to showcase what Katney's been working on, which is some awesome CircuitPython guide. So if you go to the learning system and you look at any of the CircuitPython compatible boards, we have this really nice set of guides, of pages really, that are sort of a part of the guides that really showcases how to get started with CircuitPython like right away. So what I did was I mashed up two sample codes together to make this super simple button switch NeoPixel thing. So I started off with the digital in and out sample code. And this just kind of shows you how to use a regular button and switch to light up the internal LEDs. And look at these wiring diagrams. They're so like comprehensive, right? So really, really awesome. So it shows you all the different boards and how to wire them, even the Metro Express. But in our case, we have the Trinket M0. So it walks you through exactly how to set it up and what's going on. It walks you through all the different variables and helpers that are programmed into the board, really. And then I have over here, we have a lot of different examples: how to control a servo, how to do cap touch, how to do PWM, and the dot stars right here shows you how to wire up the dot stars to the Trinket. And then we have some sample code to show you just kind of how to run a strand test, a little bit of rainbow action, and some color fills. So I've just smashed those two together to make a really simple circuit. So if anybody's really new to coding, I have zero background in programming, so it was really fun to come in here and kind of stumble on it and put this together without too much programming experience. So that's really what it's about, to help kind of people out that don't necessarily have a programming background to kind of get in here, jump in, and just get started on it. So it's really cool to see all these different things. We also have HID keyboard examples as well, which you've seen quite a few projects from us. It's so thorough. I really appreciate all the work that Kattni put into the work here. So check it out. We'll have a link in the description. And again, this is a part of all of the CircuitPython compatible boards. So that's kind of exciting for me. Yeah, so that's kind of it. You know, this circuit could probably be used for all sorts of different projects. The one that comes off to mind is maybe like a cosplay thing that needs to kind of be actuated. So if you're into cosplay and making props, maybe you want to make some sort of staff or a weapon or something that you pull the trigger and it lights up these lights. Mm-hmm. So, and again, you can switch out the button for sensors, or in this case, what we're going to do is use vibration sensors. Sweet. So that's what I'm working on. And we finally, thanks Pedro for cleaning up the coffee. Bill from 18 Makers is saying if you could use resistive stretch material to easily make it responsive. So we did come across some trampoline games for kids where they would like jump on different sections of the trampoline for like whatever game that it's playing. Yeah, so that's a really good idea to do that. Also comments from on Discord. Someone was asking, how do you go about testing your printer's tolerances? He seems to have, where is it? Let's say a verbatim. He seems to have vastly different tolerances between designs. Cool. It looks like, I'm just reading all the comments. Other than trial and error. Okay. Sorry, I'm still reading the comments. This is called, John K. saying he calls it a CPMM coding, copy, paste, meld, and morph, as meld the data and morph the code. Yeah, pretty much. Olinsky saying this would be really cool. At a pool party, yeah, for a pool party. So any suggestions for how... that's a good idea. Kind of variable brightness. So when you actually jump on the trampoline, it gets a little bit brighter. Yeah, I think there's a lot of different things you can do with it. Maybe turn it into a game, like you were saying earlier. But this is prototyping, so we just want to get that from a mechanical design standpoint, which is my hey. I really wanted to get that sorted out to make sure that when you're jumping on it, the LEDs don't kind of flop all over the place or anything like that. So in terms of figuring out your printer's tolerances, you can actually print out
one of these. We should actually make one where it's all of the different diameter sizes for that until you get the desired one. So start one having that's like at 4.8, 4.9, 5.
Yeah, I see a lot of that sort of tolerance testing.
And where it's just the top portion of this.
Right.
And that's actually how you figured out the tolerances for this when you were first building the cover for this.
Yeah.
You didn't print the entire thing, you just printed the first couple layers of that upwards. So that is a good way to test out your tolerances for your printer.
Yeah, good idea.
Asking the Discord for that. And then what else do we have?
All right, we gotta get going because we're gonna run out of time.
Oh yeah, go.
So let's jump into the next thing, which is toilet paper.
Yeah, I just wanted to bring this one up.
Do you want the?
So about 5 years ago, I made this toilet paper model. I think I did it like in Maya.
Toilet paper holder.
Yeah, toilet paper holder, and it finally broke after 5 years. So I wanted to see if that model would still print successfully, and yeah, it did. So I know that these, you know, cost like $1 or $2 like at Lowe's, but every time we would go there, I would always forget to pick one up. So you know, the cost for that was really not an issue here. It was about me forgetting every single time we would go to the store and forgetting. It was a lot more convenient to actually just go ahead and just print it out.
Yeah, practical 3D printing around the house. It's,
and the only, the only supports were on the bottom there with a brim, and no supports for the spiral little
the
spring there.
Right,
and this is what the old model looked like. And oh man, this was like one of the first couple models that we printed on the Replicator 2 in 2013. Yeah.
Okay.
And you could see like how horrible the leveling was on it. And the only reason it broke was when Gavin went up to it and sort of, you know, tried to rush and grab like a toilet paper to blow his nose, and the tip actually broke off of here. And you could see just how horrible the, well, we sliced this in Replicator G, for anybody who's been long enough remembers that old slicer. And yeah, it was mostly because of the gaps between the layers. There's only 2 shells, but it lasted 5 years. Just wanted to give a shout out to, you know, PLA lasting that long, taking all that abuse from a child, finally broke. But yeah, sometimes even though a part costs, you know, just $2, sometimes the convenience of just being able to print it and forget about it outweighs, you know, what the small cost of what the part would be.
Yeah, there's also a good point here from Bill Binko, who's saying you can internally print an oblong so it won't spin when your cat or a 2-year-old gets to it. So it's a good example of just making it custom. Maybe you know, maybe that isn't something you can buy. Customize it, tailor it to your needs or solutions or whatever.
Very cool idea.
It's really neat.
Yeah, so just wanted to point that out. Super simple little shop talk on.
It really inspires folks to kind of fix things around the house, I guess.
Yeah.
It's always fun. Okay, moving on. Let's do. I'm gonna skip the layer by layer. It's gonna be released tomorrow.
Tomorrow, yeah.
Yeah, it's kind of a hard one, but you'll see when it comes out. All right, shop talk. Let's see here. We're just gonna do a tweet, and I wanted to let everybody know again that. Oh boy, I don't have the link open. Sometimes people ask me about if I have my Fusion 360 CAD parts like up somewhere. We do. We got a GitHub repo of all the CAD drawings that I put together. So feather boards, trinkets, NeoPixel rings, slide switches, breakout boards for the micro USB, batteries, sensors, amplifiers, screens, displays. There's how many here? I don't know. It's like maybe 70 or 80 of them, but you can check them out. They're all the Fusion 360 files. If you want them as an STL or something like that, you could download the Fusion 360 file and then export it as an STL. I figured I would just give out the source so that it carries the parametric timeline, and all the sketches and dimensions are contained within that file. So that's why I'd rather give that away instead of just an STL. You have more control when you have the source. Yeah, so just another, I'll probably be doing this every week, like just reminding people about it. Let's see if I can get that in the chat. There's the link to the GitHub. if the link doesn't work, try to just search for it on the Adafruit GitHub page, because YouTube tends to break it a little bit. I'll post it as well in Facebook. So it's there. Again, if the link doesn't work, try to search for it. And it looks pretty clean there on Facebook. Okay, awesome.
Having requests from Bill to add those to all the download sections of the guides.
Oh gosh, yeah.
Wish there was a universal way to do that.
I need to pin
like
that
add to all request to Justin.
I am
Please
adding
update
that to our notes here. Give me a second to pop that in. All right, cool. And let's put that there. Okay, thank you. Good suggestions.
I'll add it to the new guides, yeah. Yes, because it is frequently asked, at least once a week, on where are parts, various different parts.
Yeah, I need to make a blog post. I haven't even done that yet. I will get on that. All right, we're going to move pretty quickly here. So we just want to let people know there's a new beta of Cura that's coming out.
3.3 was released, I believe, on Monday, and this really targeting the support material stuff that I was talking about earlier. Scroll down, they have, we'll quickly go through some of the improvements that they added to this. They added a bunch of profiles for other printers, so this works with a ton of printers. Of course, it's open source.
Free software. This is free slicing software. So if you're new to 3D printing, slicing software is what gets your 3D model into the G-code that your printer can understand and use. So Cura has been out for many, many years, and they continue to be one of the best open source pieces of software.
Yeah, it's them and Slicer that are continuously having loads of really good updates from the community implemented in. And check out their GitHub if you want to be a contributor. But they had a couple of nice toolpath optimizations. They have circular prime towers now. It's supposed to optimize the toolpaths that result in less jerky print head action, more robust structure, better layer adhesion, and better build plate adhesion.
Yeah, you can use a prime tower. Some geometries and some parts, like
sometimes
our Adabot,
you
didn't need the prime tower.
Yeah, sometimes you do need it.
Yeah, for something bigger like this, probably want to use a prime tower.
Scroll down. Support blocker. This is starting to challenge Simplify 3D's #1 feature, which is being able to place supports anywhere. While this doesn't let you place support material where you want it, you can at least block it where you don't want to. A little bit of UX, little bugginess in terms of the way that works at the moment. Just it is beta, but nice to see that it is there. I did try it out for a little bit, and it would have been really helpful in terms of blocking where support material was happening on the Adabot. As you saw when I was removing the support material right here, it had a bunch right in front of its face, which didn't need to be there. Yeah, so it would have definitely been helpful to just block all supports right around the face. Jump back into the web page for that. Yeah. So you can place those where you don't want supports to happen. Super helpful for that. You have some inspiration from Simplify 3D as well in terms of the way that it's handling bridging. So it can adjust the flow rate and the fan speed, so it will have a much nicer bridging.
Yeah, we're running out of time, so let's.
Yeah, that was like the main thing that I want to talk about. Though, so you can check it out on Ultimaker, try it out. They have a bunch of new profiles. A lot of the printer manufacturers, that's actually what they use as their customized version of that. So check it out. Go.
Sorry, it's just like. All right, we're still sponsoring this contest. You got 10 days, so if you're into designing cosplay props from video games, here's an opportunity to win some 3D printers and some Adafruit gift cards. So check it out. I won't go over the details because all of it is on the website, which is linked below. Okay, moving on. I want to give a shout out to, was it over the weekend?
Over the weekend. I can't remember what it stands for, but MRRF. I thought it was Midwest Rap Festival. Maybe that's something else. But our very own Kirby won the
Kirby is the
OpenRC.
The OpenRC Championship. So the OpenRC project is an open sourced RC Formula One race car, little one, by Daniel Nori, who's the designer behind it. He's also the designer behind the infamous Benchy, which is a great little model for testing your printer's capabilities. So Daniel Nori was there. with a couple other folks. A lot of YouTube folks that do 3D printing was there. Joel Telling was there. Garrett from Chaos Cortec with Chelsea was there. Jim Scuba was there. A lot of people were there. Maybe we'll make it out one of these years. It kind of conflicted with our schedules, but very awesome to see everybody, coming together, collaborating, and coming up with ideas. So shout out to Kirby,
community printers.
for winning. Let me skip to where he lifts the trophy. So check out the full video. We'll have it linked below. There's Kirby, super chuffed. Like, yeah, buddy, he like built this like a day before the race.
I knew that he would win, so it's like it wasn't even a competition. I know Kirby wins like everything. Like, what up? You know who won?
All right. Oh yeah, and Joel, they had a huge
yeah.
And Garrett had this huge. And we were gonna talk
about Iron Giant. Yeah.
All right, so check it out, and hopefully we'll see some more videos from the festival.
Super cool.
We got a really cool guide that just came out from Sophie Wan. I haven't had a chance to read it yet, but I'm looking forward to it. What is this? Experimenting with conductive heater fabric.
Yeah, so we released this about 2 weeks ago in the shop. It's a really cool material. Actually, about a month ago. Really cool material that reacts with heat.
Yeah, so you
definitely
get like
check
these
it out.
Colored things. Sweet. I'll have to
somebody tweeted. I know somebody tweeted. I forget the movie Watchmen. The dude with the face that changes.
Yeah. Roshaw.
Yeah, that would be awesome as a mask for that.
What?
So lots of cool ideas for making patterns and the like. And she is going through experimenting how to make wearables out of them.
I did not know this.
I know, right?
All right, we'll check the guide.
Check out the mentions on the Twitter for that.
Thorough. Oh man. All right, cool. Well, let's jump into community makes. We got a little bit of time left, so let's try to rush through this. We got a time lapse. We do a time lapse every Tuesday, where we 3D print models from the community. This one is Starman. This was designed by the fine folks from Vectory, which is a new web-based 3D modeling piece of software. Really good with doing like
organic shapes and the like. Made this really cool model of Starman. Here it is.
Yeah, so originally it's supposed to be a single colored model, but PagerDuty took a little bit of work here on modifying it for dual extrusion.
Yeah, I just went inside the web-based modeling app, Vectory. I think it's vectory.com.
Right.
And very easy to use. Everything's all in layers. And you can separate all of the parts, so I could dual extrude this guy. Did have to do some scaling modifications just so that the Roadster was a little bit more to size to the Starman. But it is in 2 different pieces. Comes right out. Some tack to hold them down. And did have support materials all on the bottom here. And I just combined the wheels so they don't spin. I didn't want to spend too much time on it. I had to start printing right away. But it's a super cool. Oh yeah, the rocket. But it's a super cool little model if you want to have a little tribute to Starman.
Yep.
There's what the full model looks like. Yep. Yeah, as you can see, he's a little bit more bigger than the actual car there.
But hey, that's very cutesy. And quite a few people have made it as well. So
Kirby says strap it to a rocket and send it into space. That would be cool.
That would be pretty neat.
Follow it with a drone and put a little parachute on it.
Somebody made the Falcon 9 rocket.
Oh yeah.
To go with it. It's
That's a cool little print there for this Time-Lapse Tuesday.
Yeah.
Check that out. Moving on to this week's makes.
Yeah. So shout out to Augustin Flolistic. He did a remix of the rolling pin and cookie cutters. So he made his own cookie cutter. Look at these adorable kitty cat cookie cutters.
Wow. Detail came out excellent. Look at that.
That's great. He printed it with Filamentum's Vertigo Gray, which is, I want to get my hands on this stuff.
Yeah, I like the sparkling material look of that.
You can't even see the layer lines. It's so good. So you want to know more details on how he 3D printed it, and if you want to support him, he has a Patreon page and he takes donations as well. He does some really great designs. You might know his low polygon Pokemon designs.
Yes.
That's Flolistic. Cool. Want to shout out Sophie Wong again. She put together, this looks like a car for some reason. She put together the USB foot switch. So thank you for sharing that with us. She printed it in golds, and she kind of
really good.
Used her own micro switch, so it works well.
Did some modifications for that.
Yeah. So
and it's working out great.
Cool. You got another make for your infamous light up sword. It's got so many makes. It's probably one of like our most made things. This is pretty neat. Yeah, you know, when we release designs, the cool thing about it is that you can use whatever electronics you like. So this gentleman here was like, yeah, I didn't use the Adafruit electronics, but thank you for sharing the file.
Very cool.
Really appreciate
That's
that.
great.
This is amazing. This is from Garrett and Chelsea, who run Chaos Core Tech on YouTube. Is it still in the right? Yeah. Yeah, so this is amazing. Please watch the video. It is a humongous Iron Giant. This is an animated feature film called the Iron Giant.
Yeah, so he's using the Prusa i3 4-color extruder.
No post processing on this. This is just straight up.
This is amazing.
Yeah, it's incredible. Yeah, so Garrett walks through a timeline, time lapse of him modeling it in Fusion 360 and in
ZBrush.
ZBrush as well to make Hogarth. What kind of name is Hogarth? It's a reference from the movie. Also, want to give a huge shout out to ScanLime. Micah Elizabeth Scott, who put this lovely video together of her Tuco Flyer project. This is a sort of a Delta robot winch thing that allows people to track their cat. So it's that motion tracking, and it's a really great example of reverse engineering. So this is a little gimbal that she reverse engineered and 3D printed and engineered and designed this crazy winch bot.
And it's interactive, so people can check it out.
Yeah,
interact
it's
with
internet connected,
cat.
so you can
super cool.
track the cat around. And there's motion tracking software that she wrote too.
Is it a OCV or?
I'm not sure, but there's
You can definitely check out
of videos and live streams. So she does live streams
every single day.
Huge, yeah. So it's awesome.
So definitely check out.
So check
subscribe to Scanline, and of course on Patreon as well if you want to see more of these awesome giant builds. Look at this; it's huge. Super awesome video too. Definitely check it out. Watch the whole thing. It's a sweet music video build.
It's a music video build. It's very soothing.
Super cool.
Yeah, lovely, lovely. And the last one I want to shout out is to Alex Hatchman, who's an old friend of ours.
Yeah, so he was at the MRRF.
Yeah, so he put together a synthesizer. He calls it Synth. It's very, very unique. It's a PCB, and it's capacitive touch.
Actually, let's let him say it.
Demonstration of my new instrument, Synth. Synth is a battery-operated 48-note polyphonic analog touch synthesizer.
So check out the full video on his Instagram page. Just want to share a little bit
full
of
of features.
Yeah,
so
it's
cool.
amazing. I think he's going to be offering it as a DIY kit. I can't wait to get my hands on it. So if you want to share some project with us, please do so. You can do so by emailing support@adafruit.com, posting it on the Discord channel, or tweeting at us. Either way works really well. Yeah, we did it. Don't forget, we have a coupon code today, which is Adabot. We're not done yet. We have more shows. Later tonight, we have show and tell. So if you want to come on the show and tell and share what you're working on, please do so. You'll get a free you'll get a free vinyl sticker, which is awesome. And maybe something else too, if you have something really fun. And then we also have Ask an Engineer, which is shortly after that. It's at 8 p.m. Eastern time. We'll have hopefully some new products, some news, some Raspberry Pi news. And a chance to win some stuff if you call in and answer questions, a trivia question type thing. It's very cool.
And then tune in tomorrow. We got John Park's workshop. We worked on some cool stuff. Last week he worked on some Tiki
themed.
Yeah, Tiki themed.
Yeah, so check it out. And Erin St. Blaine also has a new tutorial that she's working on. It's like a capacitive touch
super
pendant.
cool looking.
And Lady Ada, she just finished her round of jury duty, so hopefully we'll get some more from the desk. Lady Ada.
Yes. Welcome soon.
Yeah. So that's where we have come to the end of shows. Old ladies might be watching. Actually, I said that. Thank you guys so much for joining us. We really appreciate it, and we wish everybody good luck with their maker endeavors. Man, I really need a better way to close the show.
Thank you all for watching, and say bye to Adabot. Bye-bye.
Yeah, don't forget to make a great day.
Thanks for watching, guys. See ya.